So good evening, everyone, and welcome to OTF Connects on this lovely Monday evening in November. My name is Susan Watt, and I will be the moderator for tonight, so I'm kind of the host. I'll be working in the background and putting some links and things into the chat. Our presenter tonight is Jonathan So, who is a classroom teacher in Peel District School Board, and is pretty excited about math and technology, and he's got some great stuff to share with us tonight. I think he's pretty much a Star Wars fan as well, as you'll see. A great theme that's going through the session tonight. I recently heard Jonathan speak at I'm from Kitchener, and we hosted a TEDx Kitchener Ed event. So it's like a TED Talk, except that it's all on the topic of education, and it was our 3rd annual one here in Waterloo. And Jonathan spoke at that very effectively. I really enjoyed his presentation. So Jonathan, I'm happy to be moderating your session tonight, and I'd like to welcome you to OTF Connects, and I'll turn my mic off and turn things over to you.
Thank you very much, Susan. I can't type into the chat anymore, so I'm hoping that will fix itself. But I'll try my best to answer questions over the talk. Also, I encourage you to use your microphone if you want to share a question.
Jonathan, I'm going to interrupt because I've had the same issue. So I'm going to mention that to the Blackboard folks after our session tonight. One thing that I did find helped, if you click on the other tab that says Moderators and then click back on the Room tab, I found that fixed it. So try that out and see if that works for you.
That would be a negative.
Oh, darn. Okay. All right. Well, we'll see. We'll use your mic. We don't have a huge group.
We'll do our best.
Yeah, we'll do what we can. Yeah. Okay.
Okay, so you're here for May the 4th be with you. I will warn you, it is heavily Star Wars related. With some good Star Wars quotes, but it is about fractions, one of my big passions that I have in fractions, and this is my first OTF Connect, so I hope it goes as smoothly as it did in my head. So before we begin, I would just like to acknowledge, I know we're all in different areas in Ontario. It was really cool to see some Northern Ontarians. But we are gathered here today on traditional lands of all the Indigenous tribes and people of Canada, especially in Ontario. And I really just want to make sure we acknowledge that, especially during this week being the Treaty Recognition Week. I think it's important that we mention that. Quickly, if you would like to see my slide deck, it is free to acknowledge all the way into Google. So there's the short link. And by all means, join and see where it goes. All the sessions are on there. I'll leave it up for just a little bit more. And then, Susan's already put it in the slide deck, so you can easily just click on that. As Susan's already said, my name is Jonathan So. I teach at grade 6 in Peel District School Board at Ray Lawson, one of our balanced calendars. My family is a big part of who I am. And my resource as well, as Susan's put there, is right there. Thank you, Ruthie. And I have 3 kids. Izzy's 7, Mike is 3, and Levi is 1. And my wife is just an amazing part of my family. So with all of this in mind, a lot of the research that I've done has to do with my kids and where they've come from, but also from K all the way up to grade 8 as we go through this. So some of my goals that I had for the session, this is straight from the description link that we had. So I really want to walk you through some activities that we have with fractions, just to better understand the landscape and give you opportunities to actually see student video, doing some of the problems that we have, and a chance to engage in meaningful discussion. So hopefully we can have some good discussion around fractions and where some struggles are. And I'm hoping that we get a little bit better understanding of what some fraction content and building that into our best practices while teaching math. Some things that may help you, I know Susan's already kind of talked about the Blackboard side of it, but we will be kind of going back and forth between some videos and going into Padlet and Google Docs. So just screen capturing, if you have a Mac, just press Shift-Command-4 and then you can kind of screen capture things. If you have a PC, it's print screen. And then Chromebook is that Control-Shift button. There's a great site here in the thinking tools in omea.on.ca in the Matthews, and some we can use some fraction strips, some notepads, maybe some relational rods that you may have use of in the session. That way you can have some thinking tools as we will be solving some math. So as I said, we will have some Star Wars related themes. Do or do not. There is no try. Just bring me in some Yoda. So if we can, I'm going to try screen sharing, but for now, if we can just get into the Padlet. So all you have to do is, hopefully Susan will put in the, hi Francisca. There's the Padlet. If you can head into that Padlet, it will allow you to, just basically a whiteboard screen, to brainstorm some ideas around what problems do you think students have with fractions. And I am going to share my screen so we can see it, and I'm hoping.
And just while Jonathan is doing that, now that we've had a few links in the chat, it looks like Jonathan's slide has a link, but in fact that's just a screenshot of his actual PowerPoint slide. So you'll find that the links on the slides are not active. But I will be posting all of the links on the slides into the chat. And that's where you can click on them, and they should be active right there in the chat. So Jonathan's hoping that you'll go to that Padlet right now. So you just click on the link to Padlet 1, and that will take you out in your own browser to that Padlet.
Pizza, yes. Everything is pizza. What problems do we have in fractions? And pretty good explanations coming through here.
Jonathan, we're actually looking at your Blackboard screen, not your browser.
Well, that's interesting. Let's see what happens. Stop sharing.
And Debbie, if you can't click it, copy and paste it into a browser. And you have to use the link in the chat, not the link on the screen. There we go. Now it's coming to the Padlet.
Ah, there we go. Okay,
Debbie,
cool.
I'm going to post it again.
It's also on the screen just underneath my title too, if you need to. I see some people who have read the Fosno's landscapes as I'm getting the size of the whole matters, what fractions mean. This may refresh, so I'm just going to try to pull it up a little bit. Lowest common denominator for adding, yeah, when they get into middle school. You'll find that the lowest common denominator part is there's some other underlining problems to get to that point, so we'll kind of go through that. Hard time with the part-whole. Yeah, part-whole relationships is a big part of the fractions. Give you another minute or so, and then I'm going to stop sharing, and then we'll go. Okay. So I'm just going to try to get back into, these are all great ideas that everyone has had, and you've pretty much nailed some of the big underlying fractions that are problems that are happening in fractions. Operations are a big part of it. Understanding that fractions is a part of a set and a whole. The part-whole relationships, there are certain benchmarks that students do have trouble with. Pizza, if you hear Kathy Bruce talk at OMEA, she'll talk about we need to get rid of pizza into fractions, as it's really hard for a lot of our elementary students to understand circle representations, and hopefully one of the videos I'll show you will kind of show that. I'm just going to get out of the screen and stop the sharing. Hopefully I get back. Ah, sweet. Again, you can put your thoughts into Padlet anytime if you want, or add it into the chat. I know Debbie, you couldn't get into it, so feel free to add it into the chat there too. I sense much fear in you. We're heading into, I told you the nice Star Wars ideas. I was going to play a Knowledge Hook game, but just based on time, I revamped some of the timing, so I think I'm going to skip this for now and move on to another part of here. Hopefully the idea was to get you, I know Ruthie, I'm sorry. If there's time, we'll play Knowledge Hook. Knowledge Hook is a great game if you ever want to try it in your classroom. The game show is free for all educators to try, and it has already Ontario content in there, fractions included, and it goes from grade 3 all the way to grade 10. And so I had some grade 8 questions and grade 7 questions along with some primary ones in there too. But I thought we can actually get right into solving math anyways. So we're going to do some math, and there is another link, and this is where I want you to actually do some thinking. So I'm going to give you about 10 minutes to do some of your own thinking and paste it in there. The question is this: of the following fractions, 3/4, 5/12, 2/3, 3/2, 2/5, 5/8, which two fractions will add to less than 1? I would like you to show your thinking as much as possible, and if you can put your name in the Google Doc, you'll see when it opens up there's a bunch of tables. Pick one of them, and you can insert your thinking. If you want to use some fraction strips, you saw the Matthew website, or if you want to just type in your thoughts, you can type it in right there. And I think Susan is going to put a timer, but I'll give you about 10 minutes. Oh, there's the timer. Perfect. And I don't. Hopefully it doesn't go away if I share my screen, but it may. Okay, it'll stay on. So I'm going to share my screen, and that way we can pull in the document. Ah, sweet. Now the only thing is that with Google Docs, try not to type in the same area as someone else. There is like 8 pages of tables, so you can go down to the next page and it will allow you to type in there too. Yeah, so some people can come down in there. some of you get a chance after you finish to scroll down through some of the answers. There's someone's posted a nice little fraction strip, which is pretty cool. I see a lot of us have done some fraction thinking, as most of you have some pretty good answers already. Some similar answers to what you've already done, to a lot of people's. If you are finished, you can think about maybe where students may have problems with this question. We're about to see some student work after we share some thoughts into here too. So if you want to think more about the teaching aspect of it, feel free to add that part in too. Sorry, I keep going back and forth because I don't see the timer on my side. But 1 more minute left. Okay, why don't we stop the timer then, Susan, and then we'll everyone can finish up their thoughts. It seems like everyone is done. I was just trying to give enough time for everyone thinking. Would anyone feel free to share openly what they did? I know it's on the doc, but would anyone like to talk about it? It's okay if you don't. I'll go through some of the ones that stuck out to me. If you do want to speak up, just hit the microphone and feel free to bet in on me. But some of the ones that I really enjoyed were that some of you saw some of the benchmarks. I see kids here. I know that 5/12 and 2/5 will add to less than 1 because both are less than half. So combined, they will be less than 1/2 plus 1/2. I did try 5/8 and 2/5 using fraction strips, but it was greater than the 1, which is a really cool thing that I really try to hope my students would get to, is understanding benchmarks and where everything is in relationship to a whole and a half. And once I found that once students understood those benchmarks, they were better able to compare, and in fact never needed to even use lowest common denominators. Oh, I love that, Francisca. Also, you try to figure out amount would be in relation to money. I saw that with some of you converting it to decimals. I know many of us as adults, I know the first time I did this, I had to convert each and every one of the fractions to a common denominator until I saw what Kit saw in below. I'm going to show you one that stuck out to me too, being the fraction, and I'm hoping that I can make that bigger, but no, I can't on my end. And so you can see here the lovely fraction strips and where everything is kind of oriented. I'm hoping that that's what they were thinking of, and trying to see where everything was in relationship to that whole, or how much would that equal a whole. Yeah, at least I did the exact same thing when I first tried to do it. I do encourage fraction strips with my students, as they are, and we'll hear Kathy Bruce talk about that, as they are one of the things that that work out really well for students to think about. I'm going to stop sharing for a minute. So this next portion that I have is actually students solving this exact same question. So I know I encouraged you, some of you, to think about what mathematical big ideas will students have to understand or to solve this problem. One of the ones that they had trouble with is understanding that the greater the denominator, the smaller the piece, which is one of the biggest concepts in early fractions, especially in grade 4. Where they kind of saw those bigger numbers as separate numbers in a sense. Like a 5/12 would be the exact same thing as like seeing 12 and then 5, instead of seeing it as a whole piece of things. So we're going to watch, see, another Star Wars reference. The Force is with you, young Skywalker, but you are not a Jedi yet. So you're not there yet. We're going to watch one of my students talk. Before we do, and before Susan puts up the link, I want to preface things with this a little bit. I want you to think about what are the students doing and what are they struggling with, and then we'll go to this Padlet, but we won't go to it yet. Also, these students were my first year of teaching grade 4 at Ray Lawson. We weren't in fractions yet, but I had to do a workshop on fractions, so I pulled these kids aside and I was like, hey, let's film you doing these questions. So there's actually 3 children in this film. One is kind of down below. It is a little tough to hear. I will apologize to that, being in a room, but I'm hoping that we can you'll be able to play it. It's a 3 minute and 46-second video, and you'll have to click on the link that Susan is going to give you. There it is, and hopefully it plays, and then I'll be back in about 3 minutes and 46 seconds, depending on people's screens.
Sorry, that was the wrong link. I'm going to post the video link again. I had the Padlet ready to go and pasted by accident. Here's the video link.
Hard part of this Blackboard is not knowing where you are in the video. So I apologize if I'm talking over top of you. But if you get a chance to finish and you want to go to the Padlet, feel free to start typing in what are the students doing and what are they struggling with, or even just wonders or things that you really you may have thought about as you watch this video. And I'm going to share my screen so that we can see everything. I like the one who says the 3 twos. Where are the 3 twos? That's a big misconception that students do have with fractions, as they see both the numerator and the denominator as separate numbers and not a part of the whole, which is a big problem with our fraction system, because they're so used to seeing whole number systems versus rational number systems. Yeah, I like what you said, Mike. They have issues, or Michael, they have issues with understanding how many each of the fractional pieces they need to make each fraction. And the end goal is not to fill up the entire whole, which again is often the case, is that we as educators sometimes just say, fill in this piece. And that way they don't seem to be able to do that. Yes, CMA's part-whole relations is a big part of it. The guess and check method is definitely what they were kind of using as they go through it, just to kind of understand where they've been. Kathleen, this was, so I actually needed to give a presentation, and so I gave unfairly the task to these 3 students as I knew they could handle it. The other kids are working on subtraction questions, and so I gave them a fraction question, and then they were able to do that part to it. So hopefully that answers your question. So it wasn't diagnostic, it was just more, but it is a great diagnostic question to give. This will also be the first time they probably used the fraction manipulatives in that way. I normally, and I'll talk about that in a minute, I normally have them build their own fraction kit. So that kind of gives them a bit more of an understanding of how the kit works, and then I give them those manipulatives. But again, just trying to give the problem. But what this problem does is open up a big, huge amount of misconceptions right away. Yeah, Francisco, right at the end, you can hear the students, one student's like, oh, this is the one, and they get 5/12 and 2/5 because they're less than a half. So the fraction kit I'll talk about in just a second, and but I have kids build it with fraction paper, and then we go from there. So it looks like, if you haven't had a chance to finish the video, if you can add your thoughts to the Padlet or in the chat, I'm seeing a lot of great discussion here about students' misconceptions. But I will go on, just for sake of time and thinking of everyone's time and trying to get through to the other videos that I have. I'm sorry, Jen. I will try to talk louder. Please let me know if you can hear me. If we're good, thumbs up.
That's very loud from where I am. Jan, okay. Is there any way of you changing your volume? I don't think it's probably Jonathan.
Okay. Okay, I apologize, Jan. I'll do my best to speak as loud as I can, but if everyone else is hearing okay, that's good. So what these students, in my opinion, most of you are hitting everything that I found on the head pretty well. So a lot of the big problems was that first of all, the part-whole relationship of understanding what a fraction actually was to begin with. So the students had trouble with figuring out the denominator versus the numerator, how many pieces they needed, even the size of the piece. They didn't really understand that each of those pieces represented a part of a whole in different ways. And then as Ruthie in the chat kind of suggested here at the beginning, they kind of, with the 12ths, they were flipping them around and spatially not being able to fit them on that model. And that's why I asked that question, what's your whole again? And so that whole became that like aha moment where they were trying to fit the pieces on the whole. And near the end, that's when one of the boys realized that they had to say, they were like, oh, it had to be less than a half. And it was that a big aha moment that got them forward in their thinking. They did get caught up in the manipulatives, which I'll suggest that they don't really, you don't introduce manipulatives until they really have an understanding of them. But that's my own personal preference. So let's go back to the sharing. Again, if you have any questions, please put it in the chat or use the microphone. Jan, I am sorry that you're not hearing everything. And now my screen is lagging. Ah, there we go. Okay. So this is the portion where I'm going to kind of talk a little bit more than I'd like to, but when dealing with fractions, for me, my math class is something that not only content is important, but also just the overall atmosphere of thinking. For fractions, I create this context where the kids are building a kit. If you're familiar with Marilyn Burns, she has all the instructions, and on my website you'll find those instructions there too. Basically, she creates in primary using half, quarters, eighths, sixteenths, and then I expand that for junior and intermediate into the fifths, tenths, twelfths, ninths, sixths, and even in 7 and 8, I highly suggest that students are making this kit. And I create the context where my mom invites me over to clean her house, and she's going to buy me this huge party sub. And then my friends slowly come into it thinking they're going to get part of the sub, and we have to split these subs up into various parts. Basically, what you're trying to do is create this atmosphere where students are thinking about the processes, they're collaborating, they're talking, and they're sustaining this conversation. And the context allows students to really grasp some of the concepts that are happening. So as they're, and I wasn't going to make you do this today, but as they, yeah, the party subs, as they were cutting it up, students started to realize that the sub, this giant sub, and I showed the pictures, I don't know if you remember the advertisement of this giant party sub from Subway coming in through the door, and it was this big, huge, long sub, and they're like, Mr. So, the more people come, the smaller your sub gets. And I'm like, I know, it's so unfair. And eventually, they get to a point where students start to understand that the multiplication thinking to it and the division thinking to it, and that gets into the ninths and the, I call them odd denominators. They're not really odd denominators, but like, you know, your thirds, your fifths, your ninths that aren't so easily divided by a half. And that's where a lot of the junior students will have trouble with. So in primary, you kind of stick to those halves and quarters, and then move into those odd like fifths and whatnot, that they have to actually use multiplication in their thinking. And that's where the circle problems come in, because students can't necessarily find circumference, find radius, and divide things up perfectly, which is why it's highly recommended that you use a linear model like a sub or a brownie pan or something that is in a square base, which would really help students out a lot. This slide here came from the 5 practices, and it's something that I know some of you mentioned my questioning in through the students on the question that we just watched them do. And a lot of that is because I'm able to anticipate, monitor, select, scan, and then sequence this congress that we would have with it. And this is, I put it in almost every presentation because I think it's important that we constantly are anticipating students' strategies, which is why I had you solve it first. I wanted you to really think about what the students were doing and how they're doing. And then more importantly, thinking about landscapes and trajectories. So the nice thing about fractions is that we don't need to necessarily know all the content when I mean, we do need to know content, but the idea is that Fosno's created a nice landscape. Alex Lawson has one, and I'm going to show you one from from Bruce, Kathy Bruce, which is on the ministry website as well. I love Lisa. The 5 practices are amazing to think about. But the nice thing about the landscapes is that you can look at, if you've ever seen them, the circles are the big ideas. They're the ones that are connected to the curriculum, or as closely to the curriculum as you can. And then the rectangles are the strategies that students would use, and then triangles are the models. And each trajectory kind of is the same type of thing, but it really allows you to identify some of those big ideas and models that students would be working with, as well as helping you with those misconceptions. Because if you know that your students are, like maybe in grade 8, should be up here, and they're struggling with some of these big ideas, well, maybe it's because a lot of these smaller things down here, they haven't really connected to it. Crystal, I will do my best. Susan, if you Google FOSNOT's trajectories, or someone maybe can, and you can put the link in there. If not, I can put it in a minute. They are very worth looking at as a landscape. But what it will allow you to do is realize that maybe students haven't consolidated like fair sharing, which is the basic premise of fractions. Maybe they haven't even understood that the greater the denominator, the smaller the piece. So then when you're talking about common denominators or things like that, they don't understand where that piece came from. You'll also find in there like unit fractions, clock models, which are great for adding fractions. FOSNOT has a great string lessons on clock models, so adding and subtracting fractions using the clock to help you figure out how certain things are added together. There's a really ingenious way to help students with that mental addition and subtraction, especially in the 7 and 8 when you're going there. Thank you, Ruthie. So if you haven't read this yet, the Paying Attention to Fractions from the Ministry is a great read. It's one of the great research on it. Kathy Bruce has done a lot of thinking in it. And if you're in my slide deck and you click on that picture, it will actually bring you to the Paying Attention series. The other thing is the Fractions Learning Pathways, which this is done by Kathy Bruce. Each of these, unfortunately, this is a slide and you won't be, or a picture of a slide. So if you're in my slide deck, you'll be able to see it goes to it. You can actually click on one of these little sections here and it will bring up strategies and ideas to help you through a lot of the early ideas. She breaks it in a little bit differently than FOSNOT would. Bruce's is more of a map of how kids would learn fractions and where they need to kind of go. So first thing is to kind of understanding unit fractions. That's understanding benchmarks, understanding how things are going. And then they kind of move into comparing. This is probably where your junior grades are going to spend a lot of their times on. And then you're heading into operations with fractions and addition. The interesting part is I was reading a new book by Susan Epstein on fractions, and she kind of mentions that the addition and subtraction kind of happens along with comparing, and I would kind of agree. And then she moves into multiplication. It's another good read. I didn't put it in. I just found the book recently. But if you haven't looked at the fraction learning pathways, it's a great way to see how everything is going and where to help you understand a little bit more of how students partition, students learn fractions, and even give you some lessons on it. So to go into that, and I'm going to actually, after we play this video, I'm going to add, I think I can do this, add a new page, and you should be able to write your ideas in about what stuck with you. So I want you to watch Kathy Bruce and talk about her top 10 lessons about fractions. And I want you to, in the next page I'm going to put in, add your thoughts about what really resonated with you in what Kathy said. So this is a 5-minute video. So hopefully, again, the timing works, and I'm hoping this works, that I put a new page. Yes. And you should be able to write right into this screen anywhere you want.
So I might suggest there's a tool that I forgot to mention. I don't know how I missed it, but the communication icons, which are above the list of participants, the fourth one has a check mark on it. And why don't you use that when you're finished watching the video, put a green check mark, and it will stay there and it will tally for Jonathan, so he'll have a sense of how many of the group are finished or close to being finished.
That'd be great. Thank you so much. looks like most of us are done with the video, and I can see some really cool discussion happening, which is awesome. The question around common unit, and I can see someone typing, and you're on the right track. And unit, not a common denominator. That's exactly it. To look at this as one whole, and then we can explore 2/5 of that whole, and the idea of the measurement versus trying to figure out aligning those common denominators together. The idea around unit fractions, and we're going to solve a problem in a minute that I use a lot. Unit fractions is actually more intuitive than what we normally count as, and the problem that we have with it is that we forget the multiplication sentences that go with fractions, and then when they get into high school, they have a very hard time seeing that relationship. So for example, 2/5, they don't see it as 2/5. They see it as 2 and 5 versus 2 times 1/5. So when they're actually counting as a unit fraction, it shows that multiplication a bit more, because they often do see the whole number versus seeing it as a part and seeing it as a relationship. In fact, the early Egyptians only ever used unit fractions to solve things. And they saw them in that way. I do like that. That seems to be resonating a lot with people. Yeah, and what we see the students doing in the video is the common unit versus the common denominator. And finding a benchmark. I found benchmarks to be one of the most important things for students to realize when comparing. Even the Rational Number Project, which is a huge study in fractions, they use circles unfortunately, but the idea was that they were able to relate everything to a whole, to a half, and how far apart things were from that. So they're able to distinguish that basically the closer the piece was to a whole, the bigger the fraction was, or how far away that space was. And they were able to justify the spatial reasoning of that, which is a really cool concept. Yeah, and right at the bottom next to the sun, oh, someone put a sun and then moved. But right at the bottom, what resonated most with me is the idea of reading fractions as one quantity, 3/16, as opposed to 3/16. As I was saying, in secondary, I tutored a lot of secondary students, and they struggle with that concept because they still see the 3/16 as like 3 and 16. And instead of seeing it as a whole system of numbers. There's some really great ideas in here. But for sake of time, I'm going to move on. I'm sorry, I'm just trying to get to some videos that we can see and have some question and answer periods as well. So I will be moving. I'm just going to let someone's finishing their thought here, so I'm going to let them do that. Yes, Seema, I love that. In the chat there, counting as unit fractions also permits students to see that it is still a fraction even if the number on top is bigger than the whole number, talking about improper fractions. And I love that Bruce mentions that we should be mixing those improper fractions up. And a lot of times, even in grade 4, they look at it and they go, that's not a fraction, and or where does it come from? And it's a really cool idea to it. Alba, my students in the very first video that we watched on when I asked them, what is the whole? They had to relate all their fractions to that one whole versus thinking of it as each thing as a common denominator, which can be confusing. I also find that when students are comparing fractions, if they think of benchmarks and thinking about the greater the denominator, the smaller the piece, they're thinking of that common whole versus thinking of how do I, as we were taught, or at least I was taught, of trying to figure out that common denominator. It's okay. You can go back if you need to, but that's what she was meaning by that. Okay, I'm going to switch slides, which means that hopefully if you're typing, you might be typing over top of my next slide. I think everyone has sensed that there's some great discussion in here, and I hope people go back and read it because you're doing an amazing job participating. Yes, spiraling. Sorry, I missed that one. Spiraling is important. So, are we really doing this? Bringing some new Star Wars into here. Yeah, I want you to do some more. Oh, there we go. Yes, thanks, Susan. I want us to do some more math. And the important part is because, and I'm not going to give you 10 minutes, unfortunately, I'm going to give you 5 minutes. In order, as I've always said, in order to understand how students would actually solve problems or even to look at video later on, we ourselves as participants have to actually do the math. I mentioned before earlier on that context plays such an important role in our teaching and in helping students understand fractional concepts. So this is a question from Kathy Fosno. Again, I do love her work, but it's a sub-problem, and I changed the context. Her original context is junior students are going on a field trip, and there was 4 places that go on a field trip, and they got subs for it. And I thought the context really wasn't that important to my students at the time, so we talked about, this one came during all the floods that happened well, this was a while ago during my research. All the floods that are happening in Alberta and all the floods that are actually happening in Toronto, and we were talking about the Red Cross, and I was trying to bring in some social justice context to things so we can have a further discussion around that. But the question is very carefully worded to make students think about comparing and making fractional pieces. So I'm going to let you do this. I'm going to give you, I know it's not much time, so maybe I'll give you 6 minutes. But with recent floods in Alberta, here's the breakdown of the subs that are going. So Group 1 shared 3 subs among 4 people. Group 2 shared 4 subs among 5 people. Group 3 shared 7 subs among 8 people. And Group 4 shared 3 subs among 5 people. So the question asks us, what do you think was it? What do you think? Was it fair? If not, who got the most and who got the least? So 6 minutes on the clock. And I'll let you figure it out. You can just do it on a piece of paper or wherever you want. Okay, so it looks like most of us are, oh cool, it dings at me too. Most of us are doing pretty well with this. There's been some great discussion in here around the question. And just to address Carolyn's question around converting, as I think most of us as adults pretty much converted it. So the question I ask my students when they do this is often, how do they know what the fraction was in the first place? So my guess is you got 3/4, 4/5, 7/8, and 3/5. But how did you know exactly when that was? What I love about this question, and it is a grade 4, according to FOSDEM, a grade 4 question, but I've asked it in grade 4, I asked it in grade 5, and I asked it in grade 6. And my guess is you probably asked this in grade 7 too, and it would still be such a rich discussion that's happening because of how much assumptions are made around that, and how many, as Kit mentioned, how much like points of entry that this question has to offer. And the other part that I often ask when students do the converting is it needed? Do we need to convert? And yes, I could possibly say without converting. Is there a way to doing it? Because the way I look at it is, you can see that 3/4 is one section of the sub away. 4/5 is also one section of the sub away. 7/8 is one section of the sub away, and 3/5 is 2. So we know that it's not fair right away, because we can see that 3/5 is 2 sections of it out. So the next question is, which piece is actually closer to that whole, and which is why I asked if you had the possibility of using a number line. So if you put treat each whole the same whole. So we're talking about that common whole versus the common denominator, and you put 3/4, 4/5, and 7/8 on that number line. Where would that be? And you would realize that 7/8 and 1/8, because we know that the greater the denominator, the smaller the piece. That 1/8 is actually a shade smaller than the other one. So they actually got the most sub. And so it was a really interesting way to get the kids thinking. And we're going to watch, I have 2 videos in here. And so if you get a chance to look through them, watch both videos, but we're only going to have time for one. And I love this, truly wonderful, the mind of a child. It is truly wonderful to see their thinking. So we're actually going to look at some students' work. This is their sample of the work. I'm going to put it up because when you see the video, you don't really see it all that's happening. This is their very first attempt at doing the problem. And this is their second attempt with my help. This was my lowest group. One of the boys, as you watch the video, is not as engaged as you would hope. In fact, he in the end didn't even know how to make fractions, but by the end of my research, so it was 12 weeks of doing this, he was able to tell me all the benchmarks in his fraction kits. It was really cool to see the growth in it. And you can see the problem. I don't know if it's big enough, but you can actually see the problem that they have with circles, and especially when they get into, well, they wrote the fractions wrong, but when they get into fifths, and you can see it in here. I don't know if you can actually see my pointer. Hopefully you can. They make like this peace sign, and then they try to split things in half, and then they try to, which is what happens. Students first learn how to half things, and then they learn how to half-halves, and then they get into thirds and fifths, and they try to half those thirds and fifths in order to work it out until they figure out multiplication. Oh, I got to hold down my mouse. Okay. I don't know if that works, but. And that's the other part. I don't know why they drew circles. Circles are so ingrained in our students' minds from an early age that they think that fractions must be represented with circles, even though this context was about a sub, which is a linear type of modeling. So I had to remind them, and this is why you see my drawings in the green and the red with them on it. So this is Daniel, Harleen, and Rizwan, and this is my research that I was doing. So this is me filming and being a teacher at the same time. So I do again apologize for the work, but hopefully you can kind of hear what they're saying. And it's a short video, so have a read. And if you can, when you finish, can you put that check mark back up again? And I will we can continue on with the presentation, which is almost done. Okay, so it looks like most of us are finished. So you'll notice that there's not much time for discussion here, but you can see that this group here probably wouldn't even be on the landscape if you were to look at it. They really struggled with understanding what a fraction is, and you can see it in the very first picture on the left. When they say 4/3, they're really meaning 3/4. They even represented it right in the drawing, but they didn't represent the actual context of what was happening. And so I had to, onto the right, ask them a quick question of how many subs did you actually have? And I was trying to lean them towards that idea of a unit and trying to get them to think of using one section. And I think some of us did that in as you solved it yourself. And you can see that in group 2, where there was 4 subs among 5 people, so they had to split that up repeatedly until they got to that point, in hopes for them to see that multiplication thinking, that it was 3 times 1/4, or 4 times 1/5, or 7 times 1/8. They weren't there in this question, but they eventually did get to the idea of what, at least naming the fraction of it, which is a huge step for them. This next group here did something very similar. They were able to recognize the fraction right away, but they couldn't really explain why. And when you listen to them, they were thinking about one sub. Not, I know they drew 3 pictures, but they were thinking about one sub. And yeah, they do spend a lot of time drawing and finding markers, which is interesting to think about. But you keep moderating as you go along. And if you understand that where students are in the landscape and where they have trouble with. So students have trouble with fractions when they think of part-whole relations. Students have trouble with fractions because they cannot name what they are. They don't even understand where they come from. And students have a hard time seeing it in that context of like a whole. Like, what is that? They often are taught to do common denominators instead of thinking of it as like that unit pricing, as Bruce said. So what I like to do, why I love this problem, is because all those misconceptions come out. You're comparing, you have to think of the whole, you have to think about the part-whole relations, you have to actually name the fractions, and then this really has a rich discussion that you can bring out a lot of those thinking tools. I'm not going to show you this video, but when you're in the slide deck later on, you can see that video and you can see my questioning around that and how I got the kids to think more about the fractions. But unfortunately, we are pretty close to time. Yes, Stephanie, I will share a link with you on trajectories and landscapes. But if you go to Fosnot's webpage, she has a lot there. Also, if you are on Voice Ed Radio, which is a cool radio station for educators in Ontario, they just had a huge session with Kathy Fosnot. They actually had 3 math sessions over the last, or 4 of them over the last 4 weeks on landscapes, models, not on fractions per se, but you can really hear about landscapes and how they work. And then I would read some blogs about it. Ruthie put the landscape there. All my resources, including my fraction kit, my fraction lessons for primary and junior, are on this website, bit.ly/so-resource. Not source, as someone pointed out a little while ago. But if I thought there were about 3 minutes left. If anyone has questions, if they want to use the mic or use the chat, I'll be happy to answer them. And if there is no questions, then thank you so much for being a part of this OTF Connect, and especially my first OTF Connect. I hope you enjoyed Fraction Talk. And I am always available to chat anytime. So on Twitter is my handle there, and my email, you can find me through my site.
So I'm going to just pop in right here, and then I'll turn it back to you, Jonathan. But I'd just like to thank you for a great, great session tonight. And I really loved all the ways that you engaged our participants tonight. 2 Padlets, Google Doc, creating a slide, and you got a lot of feedback from everyone who is here tonight. And thank you to all of you for all of your questions and comments and sharings. There's been links shared in the chat and so on. So it was a really engaging session. Thank you so much, Jonathan. We really appreciate that. I think you did a wonderful job, even if you were a 10-time experienced presenter. And, you know, being that this was your first time in OTF, I thought you handled all of the, you know, options in the platform really well. So thank you very much to everyone. I'm going to stop the recording, and then I'm going to say a few other things about feedback.